Starts.
Good evening, students. Welcome back to another class. So today our topic is going to be about electric current. So we are going to talk about how an electric current behaves and what is electric current, what causes this electric current, and then we'll try to solve some numericals and understand in practical how does it behave. Okay. So would you all ask you all to pay attention to the class because it is very important. So going on. So firstly, what do you mean by electric current? Basically, electric current is produced. This current is produced when there is a rate of flow of electric charge. So you know that every material that is there, it contains atoms, right? Every material is made up of atoms, and these atoms contains electrons. So whenever there is a battery that is connected to it, so these electrons that are there in the material will flow. So if then the question comes, can all the materials allow electric current? No, it doesn't, because it does not allow because they are all non-conductors. Not every material has free electrons in it. Only those materials that have free electrons in it, they can conduct electricity. So these materials that have free electrons in it are called conductors. Okay. So how do we define this electric current? So the rate of flow of electric charge is called electric current. So again, from the definition, how do you formulate the definition? It is basically current is equals to the charge per unit time. So the rate of flow of charge in 1 second is called electric current. So how do you measure electric current? We measure electric current by amperes, which is denoted by the letter capital letter A. Moving on. A current in a conductor is due to the flow of electrons, like I was saying. But we consider the direction of current to be the opposite to the direction of flow of electrons. So when electron move, we say that electric current is produced. So this electric current that is produced, the direction of this electric current is opposite to the direction of movement of electrons. That is how we denote it. That is how we consider it. So how do you measure what is the charge of one electron? How much charge an electron can carry? So this electron charge is 1.6 into 10 power minus 19 coulombs. So this coulombs is the unit of charge. Like we have unit of current, the unit of charge is in coulombs. Okay, so wherever you have any doubts, you can put your doubts in the chat box. I'll be looking at the chat box. So if you have any doubts, I can clear them. So moving on. So like I have defined what is current. Current is charge per unit time. You can rearrange the terms to get what is charge. Charge is basically time into current. So what is charge of one electron? It is 1.6 into 10 power minus 19 coulombs. So from this, we get to understand a new law called Ohm's law. So what is Ohm's law now? So at a constant temperature, the current in the conductor is directly proportional to the potential difference applied across the conductor. So why are we talking only about conductors? Because conductors are the only materials that allow current to pass through it. That means only it can has an ordered motion of electrons. Okay, that is current. So we only talk about conductors here. Okay, so what are we saying in Ohm's law? Ohm's law says that at constant temperature, the current in the conductor is directly proportional to the potential difference applied across the conductor. While doing numericals, you will be able to relate all these definitions as a practical thing. Okay, so don't worry about it. So we can write mathematically it as V is directly proportional to I, where V is voltage and I is current. So when we remove this proportionality, we'll have a proportionality constant, which is R, which means resistance. R is the resistance of the conductor. So different materials will have different resistance, and based on which the voltage and the current that is produced will differ. Okay, we'll move on to numericals. Until now, if you have any doubts, you can ask me. I will wait for 1 minute from now. So if you have any questions, you can ask me. So put your questions in the chat box. I will be looking. If you don't have any questions, just say that everything is clear so we can move on with the numericals. If you are ready with the numericals, then let me know in the chat box. All right, we'll move on with some basic numericals in the beginning. So the question is, a certain light bulb has a resistance of 480 watts. When lighted, how much current will flow when connected across 120 volts? That is the question. So you have seen here the resistance is given in terms of watts. W is watts. So that is the unit of resistance. So mostly the way to learn physics is to by solving numericals. When you solve numericals, you learn physics more because theory is like you don't remember a lot of things. So a certain light bulb has a resistance of how much? 480 watts when lighted, but how much current will flow when connected across 120 volts? So we are talking about current here. So simple formula is V is equals to IR here, right? That is coming from the Ohm's law. V is equals to IR. What is V here? 120 volts, and we have the resistance value 480 watts. We need to find out how much current is passed. If V is equals to IR, if I rearrange the terms, it will be I is equals to V by R, right? So if I have I by R, V is equals to IR, but I is equals to V by R. What happens now? We have to do. Can someone answer? Yeah. The correct answer is 1 by 4 ampere, which is 0.25 ampere. Next question is SI unit of charge. SI unit of charge. We have just gone through the definition. What is SI unit of charge? It is very simple, basic question. The answer is Coulomb. Next, in current, electricity, the particles moving are what kind of particles move? Are the photons, electrons, protons, or neutrons? In current, electricity, the particles moving are the photons, electrons, protons, or neutrons? The answer is electrons. Yeah, I can see the answers coming in. Good. Moving on. In an electric circuit, ammeter is always connected in. Is it connected in series or is it connected in parallel? Or it can be connected anyway, or sometimes series, sometimes parallel, depending on the nature of the circuit. How is it connected? So basically, what is ammeter? Ammeter is basically a device that is used to measure current. Okay. So how the current passes? It passes through the circuit wires, right? So if you put it in series, then only you will be able to measure it, right? Yeah. The answer is series, not parallel, not either way. No, the answer is series because the electric current passes through the circuit. So if you put an ammeter in the circuit, then only you will be able to find out. So it should be put in the series. Next, in series combination of resistors, which of the following can be observed? Is the potential PD is potential difference? Is potential difference remains constant, or current remains constant throughout the combination, or current charges changes through the circuit, or nothing can be said? Just saying this. Which of the following is the correct answer? Most of you say it is one, but the answer is current remains constant throughout the combination because series is series connection, right? Next, whatever is the unit of dash. Whatever is the unit of dash. Here we have two units. One is watt, one is R. So whatever will be the unit of dash. It is a straightforward question, comes from the definition. The answer is electric energy. The answer is electric energy. Good. I can see answers. Okay. Try this question. An electric heater uses 5 amperes when connected across 220 volts. Determine its resistance. An electric heater uses 5 amperes when connected across 220 volts. Determine its resistance. So which one you have to use? You have to use Ohm's law. Ohm's law is what? V is equals to IR. V is given as 220 volts and I is given as 5 amperes. So what will be resistance? R will be V by I, which is 220 by 5. How much do you get? No, no. The answer is, how much is 220 by 5? Good, Nikita. The answer is 44. Most of you are saying 2, but the answer is 4. Simple, it is 220 by 5. Next question. Calculate the resistance of length 180 meters of silver wire with cross-section area of 0.3 millimeters square. The resistance of silver is 1.6 into 10 power minus 80 ohms meter. So what are given here? It is 1.6 into 10 power minus 8, actually, not 80. So what is given? L is given, length, area is given A, and resistivity is also given. What is resistivity? How much resistance can a material can give you is the measure of resistivity, right? Yeah. So you have resistivity, you have L, you have A. What do you have to find? Find the resistance. Basically, resistance depends on length, it depends on resistive and area, right? So R is equals to rho L by A, where rho is equals to 1.6 into 10 power minus 8, where rho is the resistivity. So you substitute these values and tell me the answer, which one you get. It is simple. You have to multiply 180 into 1.6 by 0.3 and it gives you 9,600. So because the area is in millimeters and the length is in meters, you have to convert everything accordingly so that you will get the answer properly. Okay. Moving on. A wire of resistance R is cut into n equal parts and are twisted together to make it a single wire. Calculate the resistance of the resulting wire. So if they are twisted together, what happens? N equal parts are there, they are twisted together. And so it will be R by N square. The resistance of the resulting wire will be R by N square. Now, how many 160 watt resistors should be kept in parallel to carry 5 amperes in a circuit with 200 volts battery? So you should all be remembering about the equivalent resistance in parallel and equivalent resistance in series. So in terms of equivalent resistance in series, it will be R equivalent will be equal to R1 plus R2 plus R3, so on. But here we are talking about parallel, right? So it will be 1 by R EQ is equals to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. So how many, so we have to find how many resistors are there. So let's say N is the number of resistors. Okay. So they're asking how many 160 watt resistors should be kept, right? So how much it will be? I'm seeing the chat box. The answer is 6, right? Nikita, you want me to explain the question again? Okay. The question is simple. How many 160 watt resistors should be kept in a parallel to carry 5 amperes in circuit with 200 volt battery? That is the question. So let's say if N is the number of resistors that are to be used, right? Simple. So what will be the total number of resistors that should be used? It will be somewhere R by N, because R is equals to 1 by R1 plus 1 by R2, so on 1 by N. How many should we use? R into 1 by N you have to do. So R by N. So how much do you have? You have to find out N. So before that, you have to find out what is the total resistance of the circuit. You have here how much? 200 volts you have, and 5 ammeters you have. You have to find out what is R here first. So what is R? 200 by 5, right? V is equals to IR. R will be V by I. So 200 by 5. What will be 200 by 5? It will be 40. Right? So what you have to do? 160 by 40. Good, good. Next, parallel equipment of resistance of n identical resistors is R. If these are connected in series, what will be the equivalent resistance? The question is, parallel equipment of resistance of n identical resistors is R. If these are connected in series, what will be the equivalent resistance? Very simple. I have just told you the formula in the beginning. Because it is parallel connected, it will be 1 by R equivalent. Total resistance 1 by R equal to 1 by R1 plus 1 by R2, so on 1 by N we will have, right? So we are connecting this in series now. So what will be the equivalent resistance then? So if parallel, it is by R by N. But if it is resistance, it will be N square by R, right? Simple. N square R, right? Next. When one bulb is removed from a... No, the answer is N square R, because it is not parallel equipment here. It is connected in series now. So when it is connected in series, it will be R1 plus R2 plus R3 and so on, like that. We'll go. That's the reason it will be N square R. So when one bulb is removed from a series circuit, the other bulbs, do they glow, or will they grow brightly, or it'll be as usual, or it'll become hollow? What will happen? In series connection means what happens? If in middle one of the bulb is removed, the electricity will be disrupted. So the other bulb will not glow. The question is simple, Srinivas. So when one bulb is removed from series circuit, so in a series circuit, what you have? Bulbs are connected in a row, in a continuous row. So electricity will be passing from one bulb to another once it is traveled from one bulb to another. So if I remove one bulb, then what happens in between? There will be no current passing, no, because it will be short circuited there. It will be an open circuit. The current won't pass. It is because I am not connecting any bulb there. It isn't. So it doesn't flow. The circuit is open. So there is no other bulbs that will be glowing. That is the thing. So what do you mean by resistivity of a conductor? Which of the following do you see? Resistivity of, because of the resistivity of conductor, you see increases with area of cross section. Does it increase with length? Does it decrease with decrease in length? So in the previous problem, we have used the formula called R is equals to rho L by A, where rho is the resistivity, right? So based on that, tell me how it depends upon the cross section area and length. So R is equals to rho L by A, and rho will be R A by L, right? So rho will be directly proportional to the area of cross section and inversely proportional to the length. So the answer will be increases with length. Next, resistance of a metallic conductor. Resistance of a metallic conductor. So how does it depend on the temperature? Increases with increase in temperature, or increase with a decrease in temperature, or decrease in increase with temperature? Tell me the formula how it depends. on temperature? It is direct question. It increases with increase in temperature. As you increase the temperature, what happens? The resistance will also increase. Simple. For example, you take a metal bar or anything, any metal conductor. If you increase the temperature, what happens? The resistance will also keep increasing. Next, resistance of conductor. How does the resistance of conductor varies? Is it inversely proportional to length or directly proportional to length, or inversely proportional to the square of the length, or directly proportional to the length? It is directly proportional to the length, right? Because R is equals to rho L by A. So R is directly proportional to L. Next question. Yeah, 1, 2, and 4 both are correct in the previous question because that is also same option. So heat produced in a conductor carrying current is, how is it directly proportional to current or resistance? How heat is related to current? Can anyone say? Simple. H is equals to I square RT, right? Where T is the time taken for the current to flow through the conductor. So H is equals to I square RT. So how is it proportional heat? H is equals to I square. So directly proportional square of the current and directly proportional to resistance, but it is square of the resistance. So that is not correct. Directly proportional to current? No, it is square of the current. That is the correct answer. Okay, Jizan, I'll explain. So heat produced in a conductor, it is a direct formula that is being asked in terms of the relation. H is equals to I square RT. What is T? T here is not temperature. T is the time taken for the current to flow. So H is heat. H is equals to I square RT. So what are the options here? Directly proportional to the square of the current, directly proportional to the square of resistance, directly proportional to the current, inversely proportional to time. Everything is directly proportional, but square of current is directly proportional to heat. So that is the option, correct option. First option. Yeah. So a uniform wire of resistance R is bent into form of a circle. What is the equivalent resistance between the end point of the diameter? What will be it? There is uniform wire of resistance R bent into a form of a circle. So I'll see how many of you can answer this question. What will be the answer? So when you are bending, try to see at the diameter what happens. There are points A and B. If you take a circular loop from starting to ending point, A and B will be the diameter points. At A point, what happens? It will be R by 2, and at another point will be R by 2, right? So it will be R. So how do you do it? The R by 2 and R by 2 are in parallel connection. So 2 by R plus 2 by R. 1 by R is equals to 2 by R plus 2 by R, which is 4 by R. So 1 by R EQ is 4 by R. So R EQ will be R by 4. Understood? Right. Next question. A wire of resistance 180 ohms is bent into equilateral triangle. The resistance across any two vertices. So how is it calculated? Try to solve this question. It is 180 ohm. It is not 180, 1802. It is 180 ohm. Please correct this. It's a small print issue. So you have an equilateral triangle. The complete equilateral triangle is 180 ohms. So the resistance across any two vertices, how much it will be? You can take the equivalent resistance to be 180 ohms. So how do you do it? Okay, I see almost all the options being put in the options. Okay, it is not, sorry, not 180 ohm. Don't try with 180 ohm. It is 18 ohms. Take it with 18 ohms and try to do it. So when you have 18 ohms in an equilateral triangle, how do you do it? The first two vertices will be in series. The other vertex will be in parallel, right? It will be in parallel. So the overall wire resistance is 18 ohms. So when it is bent, what happens? You give 6, 6 and 6. So two resistance will be 6 and 6 will be in series and the other one will be in parallel. So 6 will be 12. So you have to do 1 by 6 plus 1 by 12, which will be equal to 3 by 12, which is 4. 1 by 4, right? So it will be 4 ohms. Good. I see answers, correct answers as well. According to Kirchhoff first and second laws, which quantities are conserved? What are Kirchhoff first and second laws? So Kirchhoff first law says that the total current entering any junction in a circuit is equal to total current leaving the junction. Simple. That is Kirchhoff first law. What is second law? The sum of all the voltage drops in a closed loop in a circuit is always equal to 0. So in these two, what all the quantities will be conserved? Is charge conserved or potential difference conserved or energy and charge conserved? What do you mean by conserved? That means there is no energy that is being lost or any charge being lost. It is conserved. Gain will be equals to loss. That is the meaning of conservation. It is a simple question. So the answer is charge and energy. The charge and energy are always conserved according to the law of conservation. So Kirchhoff first law says that the charge is conserved and second law says that the energy is conserved. Next, what are the units of reciprocal of specific resistance? So specific resistance is nothing but resistivity. So what is the reciprocal of resistivity? It is conductivity. So what will be the units of conductivity? What are the units of conductivity? It is nothing but mph by meter. It is the opposite of ohm, mph per meter. Yeah. Next, a resistor of resistance R is connected to an ideal battery. If the value of R is decreased, the power dissipated in the resistor will be. And a resistor of resistance R is connected to an ideal battery. If the value of R is decreased, the power dissipated in the resistor will be. So how power and resistance are connected? What is the formula? It is simple. P is equals to I square R. So if resistance increases, power increases. If power is dissipated, resistor will also decrease. Simple. So you have to remember the formula. Power is equals to I square R. So you have to note down, you will be noting down all the formulas that we are being using in these questions. Then only you'll be able to solve more questions. Okay, Nikita, I'll explain again. So there is a resistor R that is connected to a normal ideal battery. Ideal battery means normal battery. So I am saying the resistance is decreased. If the value R is decreased, the power dissipated in the resistor will be. I am just decreasing it. So the power dissipated in the resistor will be, will the power decrease or will power increase? So how will you get to know this? By seeing the relation between power and resistance. What is the relation between power and resistance? P is equals to I square R, where I is the current. Okay. So P is directly proportional to R. That means if power dissipates, if resistance decreases, power will also dissipate. A piece of wire is stretched to double its length. Okay, before one. Okay. Okay, so what are the units of reciprocal of specific resistance? Specific resistance is nothing but resistivity, which we were using in the previous problems, where R is equals to rho L by A. I was explaining you, right? Where rho is basically specific resistance. Okay, so I am saying the question says reciprocal of specific resistance. The reciprocal of specific resistance is nothing but conductivity. So the conductivity units are is the question. The question is simple. You have to decode the question. So when you convert that, you get mho by meters. Simple. Next is a piece of wire is stretched to double its length, then its new resistance will be. So how resistance and length are related? R is equals to rho L by A. So you are doubling the length. Will the resistance be doubled or it will be quadrupled or it will be 4 times or it will be halved? How much? So simple. R is equals to rho L by A. L is equals to 2L. So R will be 2 into rho L by A. So it will be 2R. So the value will be double. I think there is a small error. So it will be the double the original value. If the resistance, if the length will be increased, the resistance will also be increased. So resistance of a conductor of 1 meter and 1 millimeter cross section area is 8 ohms. Its specific resistance is what? How much? So basically see here, again, like I told you in my previous classes, our units are very, very important. You have to convert units properly. Our cross-section area is given in terms of millimeter and area is millimeter square, that is, and 1 meter is the length. So you convert everything into meters and you have to do it. When you do it, what happens? It is simple. Specific resistance is rho, right? R is equals to rho L by A. Rho will be R A by L. What is R here? 8. Right, simple. What is A? 1 mm square. So you have to write in terms of meter. So 1 meter is equals to how many millimeters? 10 power 3. So because it is square, it will be 10 power minus 6. So it is simple. 8 into 10 power minus 6 by 1. So 8 into 10 power minus 6 Newton. So third is the option. Next, the current of 2 ampere passes through a coil of 100 ohms resistance for 5 minutes. The amount of heat produced is. This also we have done in the previous one. So what is the formula? H is equals to I square RT. What is I here? 2 amperes. What is R here? 100 ohms. What is T? 5 minutes. So yeah, all you have to do is just multiply and see how much you are getting. 5 into 2 into 100. But I square you have to do, which is 2 square, 4. So you'll be ending up with 120 kilojoules, which is 1.2 into 10 power 5 joules. Right? It is second option. Correct. Correct, Venkataya. What you said is correct. Next, the time taken by a 100-watt bulb to consume 3000 joules of energy. So what are we talking about here? Consuming this much amount of energy, we are talking about power. So how power and time are related? What is 100-watt bulb? What does 100-watt means? It is the power of the bulb, right? So the question is simple. All you have to work is with formula. You have power is equals to energy per time. So what is energy? It is 3000. You have to find out time. So power is equals to energy by time. Then time will be energy by power. What is energy here? 3000. 3000 by 100 you have to do. What will you get? It is 30 seconds. Right? You have to be very cautious about the units here because power is always given by energy by time. So what is the units of power? It is joule per second. So because it is joule per second, the answer will be seconds, not minutes. 30, you are getting answer. Even anyone can get 30, 300, 3000 by 100, you will get 30. But is it seconds or minutes? How will you know? Only by knowing the units of power. So power is joule per second. So that is the reason you'll be getting 30 seconds. Next, two resistance R and 2R are connected in series in an electric circuit. The thermal energy developed in R and 2R are in the ratio. So they are connecting energy with resistance here. So how do you do it? The thermal energy developed in R and 2R. So because the two resistance are connected, the overall will be, you need not calculate anything here, R equivalent or anything. So the ratio will be 1:2. Simple. Because it is connected in series. If they were connected in parallel, then it will be 2:1. But because they are connected in series, it will be 1:2. Because here we'll be using the formula of power as well. Power is equals to V square by R. So from that, we'll be taking it and we'll be understanding how it is related to energy. So it is 1:2. Next, an ideal battery sends a current of 5 amperes in a resistor when another resistor of 100, so value of 10 ohms is connected in parallel. The current to the battery is increased to 6 amperes. Find the resistance of first resistor. So what is happening? First, a 5 ampere current is sent. Then another resistor of 10 ohms is connected in parallel. The current of the through the battery will be increased to 6 ampere. Right. So what was the first resistor that you got? I want options to be told in the chat box. I am looking through the correct answers. The calculation is very simple here. All you have to calculate is first calculate what is you have to calculate what is R2, right? So from effective resistance, what do you know? 1 by R1 plus 1 by R2, right? So 1 by R is equals to 1 by R1 plus 1 by R2. You know what is R2? R2 is 10. So what you get? 10 plus R by 10R. So R2 will be 10R by 10 plus R. We know I1 is 5 amperes and I2 is 6 amperes. So when they are connected in parallel, potential will be constant. So I1 R1 is equals to I2 R2. When you do that, you will get R to be somewhere around 10 by 2, you'll get 10 by 5. So which is 2 ohms. Good, good, good. I can see correct answers. The work done by the chemical force to move positive charge from negative terminal is called. So we are talking about work here. Work done by the chemical force to move positive charge from negative terminal of the cell is called. It is EMF. Good. Next question. Which metal has least resistivity at 20 degrees Celsius? This is a right question. I see correct answers. Which metal has least resistivity at 20 degrees? The answer is silver. Correct. Next question. The current of 0.015 ampere is passing through our body. Then, can you feel it? Will it be very painful? Can it cause loss of muscle control? Even involuntary muscle contractions. What are seen? No, it causes loss of muscle control. Though the current is very, very low, when it when it joins with the voltage that is being passed, what is the usual voltage in our houses? It is 220 volts, right? So when you multiply 220 into current, you'll get the power. If you get that much power in your body, you'll have muscle control. So the resistance of discharge tube is the resistance of discharge tube is it ohmic or is it non-ohmic or is it both or is it sometimes both or sometimes this, sometimes that? It is a direct question. It is non-ohmic. The resistance of a discharge tube is. What do you mean by ohmic and non-ohmic? Non-ohmic is nothing but it varies with applied voltage and current. The resistance will be differing. You don't have constant voltage. That is the meaning of ohmic and non-ohmic. The two wires of same metal have same length, but their cross sections are in the ratio of 3:1. They are joined in series. The resistance of thicker wire is 10 ohms. The total resistance of combination will be. Two wires of same metal have same length, but their cross sections are in the ratio 3:1. They are joined in series. The resistance of thicker wire is 10 ohms. The total resistance of combination will be. They have same length. Only their cross sections are different. What is the answer? You can see 2, 3. It is simple. You have resistance equal to rho L by A, right? So R is directly proportional, inversely proportional to area. So R2 by R1 is equals to A1 by A2. Then what happens? It is 3 by 1. R2 will be 3R1. So what you have to do? R2 will be 3 into 10. It will be 30 ohms. First one is 10 ohms. It is already given. So equivalent will be 10 plus 30. It will be 40. Simple. Next. A student has 10 resistors of resistance R. The minimum resistance made by him from given resistors is. The minimum resistance made by him from given resistors is. How do you do it? It is simple. You have 10 resistance, right? So you can do 1 by R plus 1 by R plus 1 by R so on up to 10. So you'll get 10 by R, right? So what is R equivalent? R by 10. Simple. So the answer is R by 10. That is a minimum resistance. So a parallel combination of 3 resistors takes a current of 7.5 amperes from 30 volts supply. If 2 resistors are 10 ohms and 12 ohms, what is the third one? So you have current here. How many resistors are given? 2 resistors are given, 10 ohms and 12 volts. Current is given 7.5 A, 30 volts, parallel combination here, they are saying, right? First, you find out what is I at 1, what is I at 2. Then you can use total I. I is equals to I1, total I equal to I1 plus I2 plus I3. So for first, you will be getting how much? You'll be getting 30 by 10 you have to do. You get 3 amperes. For second one, it will be 12, right? R2, 30. 30 by 12, you will be getting 2.5. So what is total current? You have 7.5. I3 will be equal to 2 amperes. So V total voltage is equal to I3 into R3 you can do. We know what is V, right? 30 volts. I3 equal to 2. So 30 by 2 it is 15. Simple. Specific resistance of metals is mostly affected by. So again, same R is equals to rho L by A. So how is it? So specific resistance is a resistivity, right? Resistance depends on temperature and all. So the answer will be temperature. So the number of combinations with which can be made of 3 equal resistors is. The answer is 4. The number of combinations which can be made of 3 equal resistors. Answer is 4. Two resistors when connected in parallel have equivalent resistance of 2 ohms and when in series is 9 ohms. The values of two resistors are. It is very simple question. You need to check the options here. So what are they saying? When they are connected in parallel, the answer should be 2. When they are connected in series, the answer should be 9. So the first option, so when it is in series, what is the formula? R1 plus R2. First option do 2 plus 9, it is 11. But in series, you have to get 9, right? So first option cannot be. 3 plus 6 is 9. It can be option. 4 plus 5 is also 9. 2 plus 7 is also 9. So 2, 3, 4 can be options. Now check with parallel one. When you do parallel resistance, the total parallel resistance should be 2 ohms. So when you solve, which of these two will give 2 ohms? 1 by 5 plus 1 by 4, can it give 1 by 2 plus 1 by 7 or 1 by 3 plus 1 by 6? Good, good, good. I can see correct answers. 1 by 3 plus 1 by 6 is the correct answer. Next, the elements of an electric heater is made up of. The elements of the electric heater is made up of. We need to have a conductor, right? We cannot have any resisting, more resistance. So the answer is nichrome. For an electric heater, it is nichrome. So a heater coil is cut into two parts of equal length and only one of them is used on the heater. The ratio of the heat produced by this half coil to by the original coil is. So a heater coil is there. It is cut into two equal parts of equal length and one of them is used on the heater, then the ratio of the heat produced by this half coil to that by the original coil is how much? I'll wait for 1 minute, see and if anyone can answer. I'll see. Okay. I see a lot of confusion again here. So we know that R is directly proportional to L, right? And then P is directly proportional to again L. So P is inversely proportional to L because P is equals to V square by R. P is inversely proportional to 1 by R. And R is directly proportional to L, right? So P will be inversely proportional to L. So P1 by P2 will be equal to L2 by L1. So we are cutting L into half exactly. So L1 is equals to L and L2 will be equal, L1 is equals to L by 2. So what will you get? 2L by L. So you'll get 2 is to 1. So a 25 watt and 220 volt bulb and 100 watt and 220 bulb are connected in parallel across 440 watt lines. So which will fuse? So will the 10 watt bulb will fuse or 25 watt bulb will fuse? It is not 100 watt, it is 10 watt. Which one will fuse? Can see correct answers? Both will be fusing, correct. Because they are connected in parallel. Very simple. That's it for today. Uh, Thank you so much. If you have any doubts, I can take a few doubts. No, that's it from my side. Any doubts? Okay. Okay. I can. Okay. I don't see any doubts. Thank you so much for joining.